Here are two examples that apply the midpoint formula. The first one's a pretty straightforward question where we'll give you the two endpoints and ask you to find the midpoint, typical question. But an application of that would be I would give you the midpoint and one endpoint and ask you to find the other endpoint. So that's a little bit different, and we'll look at another way to think about this problem here in a second. But let's do our first one. EF has endpoints 7, 5, and 2, -4. What are the coordinates of midpoint M? I don't think I need to draw a picture of this, but you could. You could draw a segment from E to F and call one 7, 5, and the other one 2, -4. It's really not important that they're on a coordinate plane or anything, even though you've got the ordered pairs. If you think about it, these ordered pairs are in completely the wrong place. 7, 5 would be way over here if this was 2, -4. But it doesn't really matter. All we need to do is apply this formula, the midpoint formula. So I'm going to simply take the two x coordinates and average them. So I'm going to take the 7 and the 2, and I'm going to take 7 plus 2 and divide it by 2, comma, and then I'll do the same thing with the y values. I'll take the 5 and the -4, 5 minus -4, 5 plus -4 over 2. And now I'm just going to simply calculate that. That's 9. 9 divided by 2 is 4.5. And 5 plus -4 is 1, and that's going to be 1/2 or 0.5. You would rather leave them in fractional form. Just make sure that they are reduced. This or this would be the midpoint of that particular segment. Now, take that application to the next question. The next question gives you the midpoint and one endpoint. I'm actually not going to use the formula in the same way you might think. You could do an algebra problem and use this formula and plug the numbers you know in and then solve for the unknown values, but I like this way better. I'm going to draw a number line. Again, it doesn't matter where it is. I'm just going to draw the number line. I'm going to put the midpoint in there. The midpoint M is at -2, 1. One of the endpoints, let's put it over here, is at -5, 7. Okay, so let's find the other endpoint. Well, let's think of it this way. Since the midpoint is halfway between the endpoints, if I find this distance, I just need to apply it over here. So this distance would be the distance from this x coordinate to this x coordinate. Let's think of the x's first, and then think of the y's second. So the x values from -5 to -2 is how far. You could just sort of count it out. Think of yourself starting at -5 and ending at -2. If you start at -5, you'd go -4, -3, -2. The distance is 3 units. So the x distance is 3 units to the midpoint, so I got to go 3 more units to get over here. So start at -2 and add 3 more units. That's going to give me -1, 0, and 1. So my x-coordinate should be a 1. We'll do the exact same thing to the y value. We're going to go from 7 to 1. So if I go from 7 to 1, that means I'm subtracting 6. 7 minus 6 is 1, so I'm going to go -6 this way. I go from 1, I subtract 6 more. 1 minus 6 is -5, and that should be my endpoint.